Hi everyone, Queeveen here from the comfort of my kitchen. In today's video, we are going to talk about stars as we often do, but we're going to talk about a way that stars are classified. Stars can be classified in various different ways, but one of the easier ways, one of the more immediate ways to classify stars is by their color. Taking a look at the sky here, and we'll move forward to get the moon out of the way. Looking at the sky here, we can already see that there are different colors of stars. Some stars are more of a bluish white, some stars are more of a bright white, some stars are more of a reddish or orange color, and this is one of the ways that stars can be broken up. So taking a look at definitely quite a blue star here, this is Alnitak. Alnitak is a blue giant star. It is a big, bright, energetic, young star. Blue stars are always big. They're always giants or supergiants. Blue stars generally can't be small. These blue stars are blue because they're at a very, very high temperature. Blue is the highest temperature that we see a star, generally speaking. So Alnitak here is an O class star. That means its surface temperature is 33,000 Kelvin or more, and you have to be that hot to generate this sort of bright blue color. And we can see, even though it doesn't say it's an O class star, this writing here is all in blue because it is, oh, here we go, spectral type O 9.71b. The 1b here is to do with its size, so it is as luminous as we'd expect a giant star to be. All of these blue stars are giants, but when it comes to other colors, you can have red dwarfs and red giants. For example, if we take a click over here, we can see that this color here is kind of a yellowy orange color, and down here it is K, what looks like 3. We will get back to K. It's a cooler star, even cooler than our sun, but this 3 here marks it as a giant star, a normal giant star, rather than a luminous or subluminous giant star, which is what the 1b here is telling us. It's a bigger star, essentially. These hot blue stars are quite rare. They're the brightest, but there's not that many of them. So they're not necessarily going to be the closest stars to us. And proximity to us also makes a huge, huge difference in brightness. Here's another example, and I might be able to make a comparison here. Very similar colored writing, because this star here, 31 Orion, is also a K spectral class 3 normal giant star. So another red normal giant star. Mintaka up here, also an O type star, and Alnilam here, a B type star. So this is the next step down. B class stars, I wonder if they are, yes, a different color. So you can see this blue here is a brighter, richer blue, whereas Alnilam here has a slightly paler blue color. It's still considered a blue star, and it still looks blue, but it's a B class star, and its temperature range is just a little bit lower, from 10,000 degrees Kelvin up to 33,000 degrees Kelvin, and then 33,000 degrees Kelvin and beyond puts you in the O class type. These B class stars are also giants. We can see here it's 1A, that makes it a luminous supergiant. If we take a click over here, it's a B4 here for a subgiant, so it's still a large star. It's not a normal stellar mass star like our sun. Here we go, 5. So this is B5, and it is more of a main sequence, normal sized star. So that's probably about as small or close to as small as a star that's burning blue will get. These bright blue stars are very energetic and young, so you often see them in star forming regions, which is one of the reasons that we're seeing so many of them here in Orion. Pulling back out a little bit, we're going down now from O and B class to A class. So not in alphabetical order. It doesn't obviously make sense, but there is a set of letters with these meanings. Here we have an A class star, and it's Sirius. Sirius is the brightest star that we can see in the sky, but it's not as hot as these other stars, as these O and B stars. Its surface temperature is from 7,300 Kelvin up to 10,000 Kelvin, and then 10,000 onward is B, up to 33, and 33 onwards is O. So they're all broken up according to temperature, but their temperature does alter their color. And Sirius is this kind of whitish blue star. And zooming in here, this is really Sirius A. Just over here we have Sirius B. So this is a different type of star. This is DA. which is just a different kind of A, really. The D isn't part of the same OBA classification, but this, or the D there, presumably stands for dwarf because it is a smaller star orbiting this much larger star, the main Sirius Alpha. We can see its magnitude there is minus 1.46, but its absolute magnitude is 1.43. So if we take a look at a couple of these other stars, yeah, so its magnitude is 1.77, but its absolute magnitude is minus 4.99, practically minus 5. So this star, Alnitak, being this big O-type star, is actually brighter, but it's further away from us. We can see there hundreds of light years, 700, give or take 100 light years away. Sirius is much closer, just 8.6 light years away. So even though it appears brighter in our sky, it's brighter to us, it's not as bright as these bigger, hotter stars. Those A stars are pretty common. As we go down the list, from hottest to coolest, we're getting into more common stars. So if we turn around here, we've got Vega, another A-type star, A main sequence star. It's also nice and bright, again, partly because it's quite close to us. Deneb as well, another A-type star, much further away from us, but also a much brighter star. So Deneb is actually a brighter star. It's a higher luminosity, even than the O-type star that we previously looked at. But there's a lot going on here. It is a double star. There's two stars involved, but that is a particularly bright star, and it is very far away from us, thousands of light years. One of the further stars away that we can easily see with our eyes. And that gets harder as the stars get dimmer. So we're going from A now down to F. Again, the class system doesn't exactly follow the alphabet, but we're looking here for Procyon. Here we go. F. And I'll see if we can see a difference here. Yes, Sirius is kind of a whitish blue there as an A-class star, whereas Procyon here, much more white color as an F-class star. So again, a little bit cooler. It's going to be less than 7,300 Kelvin, down as far as 6,000. So even though this kind of star is more common, roughly a third of the stars that we see in the sky are this F-class, this F-spectral class, this sort of cooler, still not as cool as our sun, but a lot cooler than those other high-ranking stars. But they're fainter. So most of the stars that we can see with our eyes, they're going to be in a different spectral class. So I think that no spectral class is being given here because it's a double star. But if we take a look at Pollux here, we can see its spectral class is K. Many of the brighter stars that we're going to be familiar with, they're either going to be higher on the spectral class, like B there, or they're going to be giants that are lower on the spectral class. For example, Betelgeuse here, much lower on the spectral class, down to M. Aldebaran over here, K, a star as well. But these are fainter stars. These ones are big old giant stars. So because they're so large, they're able to take up, they seem a bit more imposing in the sky. Whereas we don't see as many giants in the F and the G class. The G class, of course, our sun is a G class star. So we'll have a look around here. Here's Vindmyatrix. Vindmyatrix is a G class star. It is a similar kind of star to our sun. It's G class. And of course, there's many differences. It's a 3B, so that makes it a normal giant rather than the V, the main sequence size of our sun. So these colors don't necessarily tell you the size, they only tell you the temperature. In the case of these G stars, less than 6,000 degrees Kelvin, down as far as just 5,300. So that is a star that very rarely has giants. There are yellow giants, there are yellow giant stars, but they're very rare. Yeah, Polaris here is another F-type star, but it's an F1b, so this is a giant F-type star. For both the G and the F-type stars, these giants are less common. For the last two classes, the real orange and red stars are K and our M class, with examples here of Betelgeuse and Aldebaran. These types of stars are very common. Red stars in the K class, like Aldebaran, going from 5000 Kelvin down to just 3900 Kelvin, and then red stars in the M class like Betelgeuse going from 3900 down to 2300, so much cooler. These colors of stars are some of the most common, and we do see these giants. This is a red giant star, and even this one over here, it's 3, so it's a kind of a normal giant or a subgiant, not quite the super giants that we see in class 1 and class 2. These stars, these red giants, they're not super common. Red dwarfs are, however, the most common stars that we see or don't see, unfortunately, in the universe. No red dwarfs are visible to the naked eye. Even if we push out into the countryside here so that more stars are visible, if we randomly click around, all of the stars visible to the naked eye, we've got a B class there, we've got a G class there, like our sun, that's nice. Even the fainter ones, there's another A class star, clicking down here for a very faint star, G class like our sun. None of the stars that are dwarfs, smaller stars in this K, so we can see here, this is a K class star, it's 3, so it's considered a normal giant. Definitely not one of the much more common red dwarfs. And we can see, clicking through these stars, how stellarium changes the color of what's written. Here's another F-type star. Not very famous stars because they're often not the brightest, so it's nice to find another F-class star as an example. But we can see how the color is changing in the writing there to match up with the color of the star. For red dwarfs, we really have to search for them. So I'll search for my favorite, Barnard star. It's under the horizon here. We are in Ophiuchus, so we'll come up here to morning time. We're starting to see the scorpion coming up there again, coming back out around the side of the sun. So here's Barnard star. If we take a look, it's an M class star, V. So this is a smaller star in the M class. This is what we would consider a red dwarf. Our sun is a V class as well, like our sun. So our star, our sun, is a yellow dwarf. But these red dwarfs, they're very common, but they're very faint. They're very difficult to see. So that is the classification. That is those are the colors of the stars. There's really only a few of these spectral classifications. We've got our brightest O-type stars, like the ones in Orion here. We've got our second brightest B-type stars, also like this one here in Orion. Then we keep going down to fainter, cooler stars, like Sirius there as an A-class star. And then we keep going again down to the F-class stars. All of these classes are still hotter than our sun. We finally come around to G-class stars like our own sun. And if we pull up a little bit here, like Vindemiatrix. So then we can continue down past the G-class stars to the K-class stars like Aldebaran, and then down again to the M-class stars like Betelgeuse. So those O-class stars, the biggest, the brightest, the rarest. These M-class stars, some of them are very large, most of them are very small, and they're the coolest and the faintest. So that is spectral classification. A few examples of them, the colors that are involved, the temperatures that are involved. I very much hope that you enjoyed this video. If you did, please do like it. If you're interested in this kind of topic, then please subscribe to my YouTube channel. And if you'd like to read some of this information, you can do so on my website, queebeanscontent.ie. So thank you very much for watching, and hopefully I'll see you back here next time.